This is the last discussion that we're going to have. Synthesis is basically a challenging problem in your exam or in your research, and that's why I ask you guys to do the mechanism flashcard from the first mechanism that you have learned, which is the halogenation of alkynes. Later, you learn SN1, SN2, E1, E2 of haloalkyne. Now, I think Sarah Levens started to talk about alcohol and ether. So she will finish ether next week. Then that means there are two more chapters. There are more reactions and a mechanism for you to combine into your reaction map. I hope you guys have started to develop your own reaction map, or at least you have some of the flashcards ready that you are going to combine them into a large map. So today, let's get started. On the discussion menu, there are some fundamental parts, which is what is organic synthesis and what is the typical step to do organic synthesis. So applications, method. So look at the target's molecule and find the carbons that present in both molecules. So this step is a useful one. Usually we're going to number the carbon. You haven't learned any carbon-carbon bond breakage in 118A. So you are only going to learn the reaction that is going to add a carbon on. So that's a good news. So when you go to 118B, then you also need to start to summarize what are the type of reactions that is going to break in the carbon-carbon bond. So later when you see there is more carbon in the target molecule than your starting molecule, you start to think, okay, there must be a Grignard reaction. Have you learned Grignard reaction? Grignard reagents. There must be something like that because that's one of the way to add carbon on. Well, there are more methods, but that's something you can start to summarize when you are learning each chapter. So synthesis is not a chapter. It's not a chapter that we're going to teach you how, but it's a chapter that by the time you are summarizing or reorganizing your reactions that you learn in lecture, you start to gain these skills. Some of the people can find a way to do that in their mind, but I prefer you to drawing them out, which is the reaction map. So, well, that's the first thing. Well, the second thing is finding the changes between starting material and the product. So what atoms need to be added? What atoms need to be removed? In 118A, the only thing you learn to remove something is elimination, and that elimination is not eliminate carbon. It's just leaving group, or it's just leaving group or hydrogen. So far, it's, I guess in 118A, all the kind of questions that you're going to see is going to be carbon addition, okay? And determine which changes are carbon-carbon bond forming reactions. See? Okay, so that's follow up. Okay, well, there are a bunch of things that you should go through, but actually reading the paragraph here is not going to help you that much. Here, consider the step 5, the list of reaction in step 4. Where is the list of reaction in your reaction map? Okay, so let's do the exercise, do the example here on discussion menu. So it has been given an alcohol. It has been given an alcohol. We know it's an alcohol because there's an OH, and then there is a double bond. How about give you 1 minute? Don't go to the next page. Okay, so let's just follow the discussion menu. We are going to exercise on the discussion practice, okay? When you see a double bond, you know there is definitely an elimination. If I just number the carbon from the hydroxyl, 1, 2, 3, from the cyclohexane, 1, 2, 3, 4, 1, 2, 3, 4. So I know it's still the number 4. That's definitely going to be an elimination on carbon number 4. Okay, so those are the carbon added, and so far you have only learned one reaction, which is carbon addition reaction. So what is that? It's the Grignard, right? Even you haven't started, just by numbering the carbon, you start to think, well, I kind of know that I must use Grignard reagents because that's the only carbon addition reaction I've learned so far. So what's the condition of using a Grignard? Then it's going to be a carbonyl, right? So it needs to be a carbonyl in somehow. So my RMGX can attacking on that. And there are two R. So this is one of the R, and this is the second R, right? So second is here, the second R. So there are R1 and R2. So R1 is this one, R2 is this one. So I kind of know these two extra R group are added through the Grignard reagents, and I just need an carbonyl. And it's easy to get carbonyl because I have hydroxyl group. So I just need to oxidize that. But that's kind of the way you think. If it's an exam that you're supposed to write, so let's see how the points is given. For example, this one. Usually, if you have right and correct intermediate, which is the product like this, it's going to be 2 points. And if you have got the condition correct, it's going to be 2 points in the middle. Okay. So the things that what are the common mistakes that I've seen students doing is first they forgot to put the solvent. For example, PCC. I think so far in lecture you should have learned PCC, which is the oxidation. This one is polar aprotic. So people forgot to put the solvent on because PCC, if you're putting the PCC in a polar protic solvent, it's not only going to stop here in aldehyde. Especially if you are using water, then that's actually a Jones reagent. So the only difference between PCC and Jones is whether there is a water or not, okay? So that the solvents actually matter a lot, but people usually forget to write them. And you should have the reagent and the solvents written as the way that we have teaching, including 1 and 2. So step 1 and step 2. You need to have those steps. Otherwise, we all know this is a good base. So Grignard reagent, so this one equals to RMGX, right? So this is the R. So this is the R group, okay? And this one equals to R minus Mg2 plus because it's metal, non-metal. It's ionic bonded. So R minus is a strong base. I hope you can find that in your table 7.4, okay? It's a strong base. If you don't write 1 and 2 in the front, this strong base is not going to react on your aldehyde. Instead, it's going to react with your acid, and that would be no reaction. So that's a very, very tricky reaction question, which is if I'm giving you the Grignard reagents, the same condition, but I'm not giving you step 1 and 2, this would be no reaction. Okay, so you got to have the 1 and 2 in the front. Okay, so that's the common mistake. And when you have that, this is just the Jones. So Jones, you use Jones to do a oxidation and add another R, which is the R2, and then just do the elimination. Okay, so this step is just an elimination. By the way, what type of elimination is this one? So I'm just writing an E. So this is the stuff that you are supposing to learn in your before your second midterm, which is today, I know. So what type of elimination is this one? So check there's a good leaving group, and this is a tertiary, and this is a small strong base, right? So this is a small strong base. So what type of reaction is this one? Okay, so as you can see here, even it's just a simple reaction like this, it requires you to have solid background in chapter 6 and 6, 7, 8. So another method, which is the approaching B here, the words that you should learn is the retrosynthesis, okay? Retrosynthesis means you go from the end, which is you just observe what is the product. So like this. This is the target molecule, and you use this double N arrow. So this is the only place in organic chemistry that you're going to see this kind of arrow, which is double N arrow. It goes into the direction which is back forward into the reactants. All the intermediate here in the middle is the steps that you start to think, like I have my R1 for sure, and then I have my ketone. I start to think, what else should I add? So that's the way, like you are trying to break the bond here, then it's going to be a step forward and all the way go back until you see the react. You don't have to go this way if you can do it just starting from the reactants that is given, okay? Have a try on the first 4. So I'll give you 4 minutes. I don't care how you do it. I just need to see a possible route. So that's the rule of the exam. It's similar to the NMR. I don't care how you solve it. I just want to see the correct structure. So the first one, we're just going to start from maybe reactants, because alkyne. What kind of reaction that you have learned in alkyne? So there are only 2 reactions you learn. Probably you can only remember haloalkyne, which is the halogenation of alkyne. Okay, so that definitely is. But there is one more step before that, which is you're going to open the ring. Okay, you learned in maybe chapter 5 or 4 that this is going to have a very, so the angle strain, there are huge angle strain. There are huge angle strain in this compound. So under the condition of hydrogen, which here is PD, okay? And the hydrogen and the catalyst is going to open up. So what's the next step? I guess that's going to be no doubt, because you only learn this reaction. It's like that's the only way to get out of the city. If you want to go to another city, and so far you only learned the only possible route is this one. So whenever you're going to see an alkyne in the exam, there's no doubt that you are going to use halogenation somehow. Otherwise, where you are going to get started? Alkyne is not going to react with anyone else, only unless you change that into haloalkyne, okay? So that's going to be on the secondary. And then you get stuck here, because there are a bunch of reactions that you can go from the haloalkyne, because there are substitution, there are elimination, and there is something more. You haven't learned. Yeah, you can go to Grignard reagent if you want. Grignard reagents. There are so many choices in haloalkyne. You don't know which step that you are going to learn. You are going to go to the alcohol, right? But let's see, can we do something from the alcohol then? Count the number 1, 2, 3, 4. 1, 2, 3, 4. Okay, there are no addition of carbon. There are no addition of carbon. So I know we're not going to use Grignard because I'm not adding a carbon on. Then I guess it's either going to be substitution or elimination. And in this case, there is not going to be elimination because I'm not forming a double bond. So substitution would work. And now the problem becomes, how do you go from a secondary bromo into a secondary alcohol? So a quick review on the table 7.4. In the block of secondary, okay, in the secondary carbon, there is a box, right? So there's SN1 or SN2, depends on the solvent. And then if you want to choose SN1, it's not going to be a very high yield reaction, but it's an exercise, okay? You can think about that. So let me just copy paste the table 7.4 here. So 1 minute. Nice. I'm going to copy and paste this table with me all the way, okay? So this is the table 7.4. So you guys is going to know what I'm talking about, okay? So this is a secondary bromo. So secondary is this one, right? So that's secondary bromo, and I'm going to change that into alcohol. And if I'm using a weak nucleophile, like just water or kind of, it's going to be SN1, right? The yield of SN1 is not going to be very high. So there's another choice, which is I'm going to use a good nucleophile, and I'm going to force it to only form the target molecule I want, okay? So in your exercise, you can go away from SN1 if you want, but it's not going to be high yield. What we are going to do is, so you're going to do an SN2. You can use a bunch of nucleophile or good leaving group as you want. It doesn't have to be the same with the answer key. But I'm just writing one of the possible routes here. Okay, there are more than one way to do that. So this is the intermediate. Why you are not showing? Okay, so this is the one of the intermediate. You can go ahead to find what's the condition for this one. Okay, go to fill the rest of them when you are on your own. Okay, so I'm just trying to solve what I'm thinking, and I'm going to cut and copy paste this table with me. Okay, I'm going to have my table next to me. I like my table. Okay, I'm going to put my table here. So where should we get started? Oh, there's a question, right? Wait, why did we use that nucleophile? Because you want to do SN2, not an SN1. So you can find other. So how does that give alcohol? So when you have that, this is later you are going to learn the name of this one is actually going to be an ester. So, and how does that give an alcohol? It is you can hydrolysis this one easily under either acid or base condition. Okay, ester hydrolysis. You haven't learned this reaction yet, but you will. So question B, the first one is an epoxide. Did you learn this? Did you learn epoxide? I guess not, right? Did you start to learn ester? Did you start to learn ether then? So this would be in the chapter of ether. So this is an ether. It's not ester, it's an ether, okay? This is a special ether, which is an epoxide. You are going to learn epoxide can be open in different conditions. So far, you just need to know. So this is something that Sarah Levens will teach you at the end of the quarter. So maybe next week. But let me just quickly summarize this a little bit, because when you see epoxide, this is what you should start to think. Okay, epoxide. If I have a methyl group here, okay, if I have a basic nucleophile, then my nucleophile is gonna to attack on the less steric hindrance side, and it's going to be an SN2. If I have an acidic condition, I guess you're going to know what I'm going to write. It's going to be SN1. And it's no longer going to be attack on the side that's less steric hindrance, which is the side that has less carbon or substituent. The first step would be protonation of the oxygen. And then after the oxygen is protonated, it's going to do an SN1. So once the oxygen is protonated, there's a positive charge. Nice. And then even before my nucleophile attack, my ring is going to open. And then this is the hydroxyl. I'm going to form carbocation. And this is also the reason that it's going to open the site that's with more carbon substituted. Okay, so which means the nucleophile is going to attack on the side with more carbon. To summarize that, Sarah Levens is going to go through what kind of nucleophile that you're going to see in the exam by the end of this quarter. But by the time there, we are not going to have discussion. So just for the take-home message for today, for the epoxide, if it's basic condition, it's going to open on the side that with less substituted. If it's acidic condition, it's going to open the side with more substituted. Okay, so just leave them there. Okay, have that message in mind. Let's start to see what can we do with the question here. Let's number the carbon. 1, 2, 3. I know the one with, there are 2 oxygens, so 1, 2. I don't know which one is my original, oxygen, but I do know, I think this is my original carbon, and 1, 2, 3. That sounds like a good idea to me. So I think this is my, or this 3 labeled carbon is my original carbon that's was given in the reactants. So the rest of them should be the adding on. So what are they? What has been added? A methoxy and an R group, right? So start to screen in your head. What are the kind of reactions that is going to add carbon on? Let me color them with a different color. So the methoxy, I think that's going to be added, and then open my epoxide in a way because methoxy is added on the less substituted side, which is added on carbon number 1. So carbon number 1 is less substituted than carbon number 2. So although I don't know how the epoxide is open, but I know it must be just from methoxy is on carbon number 1. I know it must be open under basic condition. And I just need to find a suitable nucleophile. So that's the step, that's the first step. And then this is basic. Oh, maybe I should use color blue so it's consistent with my notes previously, but never mind, just for this question, okay? So this side is going to be like that. And then my previous OH. So I'm using the black to show that this OH was from my original molecule, okay? So what else? What else? So I'm here already. What else do I need? I need to add that purple R group on, right? So I'm going to give that R group a name. So you are R now. So purple means equals to R group now. So there's only one reaction you learned, which is Grignard reaction. So I know the last step. The last step must be RMGX or RLI if you want. So you can use lithium if you want. And the second step should be acid workup. Okay. So what's my previous step then? I think it's going to be still, let me copy paste this one here. So it's still going to be that, but since I'm adding the things on, I think my last step should be an addition of R group on a ketone. And then there are only one possible route to go from my hydroxyl to a ketone here, which is PCC. Well, you can use Jones as well. So PCC. I don't know why my pad is very slow today. DCM. I don't care. So the solvents, don't forget to write the solvents. Okay, any questions? DC, oh, my M is not. DCM. Okay, so any questions? Or you can use Jones, it doesn't matter. So the first question is, what is the relationship between the double bond and R group? The double bond and R group. Do you mean the CO double bond? The second question is why and how we got double bond. You oxidize. Okay, so for the first question, have you learned this reaction or not? So let me just so how far you have learned in your lecture for hydroxyl, for alcohol? Have you learned the oxidation? Have you learned the reduction? For whoever asked that question. So if you don't know what's the relationship between the CO double bond and the R, is under the notes of reduction of ketone or aldehyde. Okay, so this is Grignard reaction. If you don't know what's the relationship between alcohol and the ketone, which is the second question you are asking, why and how we got the double bond, is under the notes of oxidation of alcohol. If you don't know what I'm talking about, you should make flashcard of both reduction of ketone or aldehyde or carbonyl, and the reaction of oxidation of alcohol. So those are two important kinds of reactions that you learn in the chapter of alcohol. Okay. How about let you guys try a little bit on compound C? Let me just give you 2 minutes to exercise on C and D. I guess by working through A and B, you should have a general idea of how those reaction works in synthesis. Okay, I'm going to pause for 2 minutes to let you guys exercise. And I don't know why my pad is very slow today. I'm gonna to reopen my pad, so maybe it will get faster. And aldehyde. So when I add my R prime on, this R prime is going to add it. So for the one who don't know the relationship, it's like the previous one, okay? So R prime is going to attack here. And the second step, the oxygen, the O negative is going to grab the hydrogen plus in the solvent. But in a problem of synthesis, you don't have to show the mechanism, okay? So keep in mind, mechanism question is mechanism question. Synthesis, you don't have to show the arrow pushing. And we're going to dot point if it's in an in-person exam. If you show something else, it's adding the work of the grader, okay? So, and what else can we start? Can we think about? In your step, because it's 118A, then this is the only place, I guess, the only time in the study of organic that there is no doubt for you. The previous step must be an oxidation. It must be PCC, DCM. Why? Because you haven't learned other reactions. Did you learn other reactions that can go to aldehyde? No. You're going to learn that in 118B. There are more. So when you, with the time that you are going to learn more reactions, you're going to make the choice. How should I, there are a bunch of ways that I can make aldehyde. Then which way should I use? But so far in 118A, there's only one way, which is the oxidation of alcohol. Then no doubt this step is going to be an oxidation. Then what's the step in front of that? Okay, so it's going to be OH. Now how should I go from my haloalkyne to hydroxyl? I guess that's easy then. Okay, so any question on this one? No? Okay. So let me move on to the last one. So compound D, or question D. So when you see aldehyde, and this is the only place in the whole process of learning organic chemistry that you only learn one method to react with aldehyde, because you haven't learned others, which is the Grignard. Okay, so even I don't have to go through what are my possible intermediate. I even didn't number them. I know it's going to be an RMGX. So RMGX. So okay, there's one more thing. I'm writing RMGX here for saving the time, but in the exam, you have to show what is R. So you need to show what is R. Okay, I'm just writing the RMGX in exam. I'm just writing R for saving the time here. Okay. So here, so then what is R then? So my R. So let's start to count. So here is 1, 2, 3, 4. 1, 2, 3, 4. So I know this is going to be one R, and this is going to be another R. Okay, so this is R1. This is R2. So R1 MGX. So if I have R1 MGX, what am I going to have? So this is hydroxyl, and this is the original H. And my R1, which is an acyl, is going to be like this. Okay? So what else? So I just need to oxidize that again. So PCC, ECM. My R, my new R, I'm going to just use the, yes. Okay? And do the second R, okay? So R2 MGX. Do you want me to do more exercise, or you want me to maybe summarize it a little bit? So previously I asked you guys to do a flashcard. I don't know how far is that. So let me just let me find. Okay. So even if it's not for the reaction of synthesis, you should start to do exercise of this kind of thing. So first, for example, I hope you are getting a blank paper now. So you start a new page on your notes, or start a new page on your pad, like what I'm doing here. And in the center of your paper or your pad, you're going to write whatever. So for example, I'm just randomly writing something. I don't know what I'm going to write, okay? So for example, I'm writing an alcohol. Now I start just from the randomly started compound you're writing. You start to see what kind of reactions that you can put it on. So go to your flashcard and to find that things now. Okay, just from the reaction we used in the discussion, just now, the previous one, what did we did? So we did oxidation, right? And actually there are two kinds of oxidation, okay? So we did, wait a minute. Nice, okay. So what else did, what did we do? So we did oxidation, right? So if it's oxidation, it can be PCC with solvents of DCN. So what did we get? It's the oxygen. It's an aldehyde. Okay, so that's after we oxidize that. That's after we oxidize that. And there are two oxidation reagents you learned, and so far, you also learned Jones, right? So if you are using Jones, then this one is going to become carboxylic acid, right? Also, if you want, you can directly oxidize that into Jones, into carboxylic acid with the Jones reagent. Okay. So how should we get back? Can we get back? Yes, we can. I'll leave this blank so far for now. I hope you can find the things. Okay. So what did we learn in the chapter 7 then? So alcohol can also go. So there, one of the ways to make alcohol is from haloalkyne, which we just did some practice on, right? So this one we should change the alcohol. So this is going to be an X. So I'm going to use maybe yellow. So this is going to be an X. Okay, X can let me use X. Okay, so X can how can we turn haloalkyne into alcohol then? So what are the methods? So one of the way is going to use HX. Okay. Or there's another way which we just talk about, is the oh no. So the HX is the way to come back. One of them is going to be SN, no, not SN1 on the primary. So SN, now I'm just writing in primary, so not SN1. So one of the way is the one that we just write is RCOO minus. The second step is hydrolysis of an ester. Okay, that was the one that we just did in our exercise. And what are the way to go back to haloalkyne, which is HX. Okay, so there's another way as well. So what else did we learn in alcohol? You can also make that into double bond, which is alkene. You're going to learn that in 118b. Let me change another color. So 118b, you're going to learn alkene. But just in the chapter of alcohol, you also learned that, right? So you can go to alkene by cook with concentrated sulfuric acid, right? So concentrated sulfuric acid, high temperature, right? So how should we get back? So you are going to learn how can you get back in chapter 12, 118b. Okay. So what else did you learn for alcohol? You also learned ether, right? So here, what kind of ether that you are going to make with this one? I guess it's going to be this. Right. So how could you make alcohol into ether? You learn several ways, right? So the first one, so I'm going to put a, so the first method you learn is Wheelian ether synthesis. Okay, the first one is going to use a base, and the second one is going to use the Rx, which is whatever the other side of the R is. So R prime X. So that's so this is WES, Wheelian ether synthesis. And there are other ways to do that as well. So I will just leave the blank here, because you can go. Ether. Let me also change the color of this sign. So green. Okay. So what are the ways that ether can go back? Dilute sulfuric acid would work. Okay. So I'm just using the chapter that we have learning so far as an example, because I haven't filled all of the parts yet. So like this is chapter 6 and 7, right? The whole thing here is chapter 8. The thing here is chapter 9, and the thing here is chapter 11 and 12, which you're going to learn in 118b. Did you see the relationship? Did you see the relationship between those chapters? We are responsible to teach you reactions, but we are not responsible to teach you how to connect them together. I'm just randomly use one of the alcohol. I start with an alcohol on a piece of blank paper, and start to see what are the other reactions that I can go with it. You should also do that. So you should. I'm only using the primary. So I'm only using the primary alcohol here. You should also try to maybe start with a secondary alcohol, and do the brainstorming again. A higher standard would be writes what type of the mechanism this one is. For example, I'm using purple. Okay, so this one is going to be SN2. And this is hydrolysis. And this is oxidation, right? And how about this one? So this one is going to be E1. Right, so Wheeling synthesis, the first step is also going to be SN2. Okay, so you should have those things in your mind, and then exercise on those. The next requirement would be, is this the only possible route? Like I'm going to tell you here in the place that I'm putting a check here, there are more routes. And then starting from ether, you can also do a bunch of things, which you should fill your map with all kinds of reactions that you learn. Okay. So that's the method that I can teach you to reorganize your reactions. And it's going to be helpful if you have this exercise at home. And then when you see the problem of synthesis, then you start to think, oh, I see this kind of reaction somewhere. Okay. So I think there's a question, right? Where is that? Oh, could you scroll down a tiny bit, please? Okay. Is the page here fine? So I'm actually finishing here. So you guys can ask questions. Maybe we just stop here. We're still going to have a discussion on next Monday, but I guess I'm still going to only see you guys on next Monday. So that's what do you guys want me to talk about on next Monday? Because next Monday is going to be optional. So what are the topics you want me to cover then? We don't have a discussion tab on discussion menu. Okay, so I've seen votes for mechanism and spectroscopy. So that's easy. So what's the mechanism that do you want me to go through then? Well, let's see what's going to happen on Monday then. Okay, so I'll prepare the things that you ask me to go over. And that's the end. Okay, bye people.